out there in space, where the stars twinkle like tiny diamonds, there's this awesome place called Proxima B. It's like a cool mystery waiting to be solved, and humans have been super curious about it for ages. But guess what? We've got this super-duper telescope called the James Webb Telescope, and it's like the ultimate detective for space stuff. And just recently, it sent back the clearest picture ever of Proxima B. So, what's the big deal about this planet? Why has it been so mysterious? Let's dive in and find out together. The history of James Webb Telescope. Billions of years ago, when the universe came into existence, galaxies began to form. Now we have an advanced tool called the James Webb Space Telescope, or JWST. This telescope could help us explore the farthest corners of space. Instead of using regular sight like our eyes, it uses special glasses called infrared to see things we've never seen before. It's like putting on magic glasses and suddenly seeing a whole new world. With the JWST, scientists can study how galaxies, stars, and planets were born. They can even use it to look at planets outside our solar system, searching for signs of alien life. The JWST is a camera with incredible filters, helping scientists capture different colors of light to learn more about what's out there. And guess what? It's made some fascinating discoveries. For instance, it found out that there's even more mass in the universe than we thought, hiding in gigantic galaxies like hidden treasures. So, with the help of the JWST, we're unraveling the mysteries of the cosmos, one galaxy at a time. But there is more. What is Proxima B James Webb Telescope? Just announced the clearest image of Proxima B back in 2013, scientists made an astonishing discovery. They noticed a tiny pull, like a gentle tug, between a planet and its star. This planet was later named Proxima B because it orbits a star called Proxima Centauri, which is the closest star system to us after the Sun. It's like finding a new friend right next door. Proxima Centauri is part of the Alpha Centauri system, which is about 4 light-years away. This means that when we look at it, we're seeing how it was 4 years ago. It's like looking back in time. Proxima B, on the other hand, even though it's just 25 light-years away, which sounds far, it's one of the closest planets to us that's outside our solar system. Imagine being able to visit a new world so close to home. Proxima B is a bit bigger than Earth, about 30% more massive. But here's the exciting part. A year on Proxima B only lasts 11.2 Earth days. That's because it's so close to its star, orbiting at a distance of just 7.3 million kilometers, which is way closer than Earth is to the Sun. Meanwhile, you might think it would be scorching hot being so close, but Proxima Centauri is a tiny star that doesn't give off as much heat as our Sun. So, what would it be like to stand on Proxima B and look up at Proxima Centauri? Would the sky be a different color? Would the star look bigger? These are the kinds of questions that scientists are excited to explore as they learn more about this fascinating planet. The mysterious surface. The mysterious surface of Proxima B. Imagine standing on Proxima B and looking up at its star, Proxima Centauri. Instead of a bright yellow sun like we have, Proxima Centauri would look like a big, dull red ball in the sky, about 3 times bigger than our Sun. Interesting, right? And if Proxima B is in the Goldilocks zone of its star, which means it's not too hot or too cold but just right, there could be liquid water there. Liquid water is extremely important for life as we know it. But before you start planning your space vacation, there are some things you should know. Proxima B is probably tidally locked with its star, which means one side always faces the star, while the other side is always dark. That's not very comfortable for any living things. Plus, any water on the planet that gets too close to the star would be heated up and turned into steam by the star's powerful radiation. On the flip side, if a planet is too far from its star, it would be too cold, and all the water would freeze solid. Proxima Centauri might not be the best host for life either. Even though it's much smaller than our Sun, its nuclear fusion cores are closer to its surface, causing a lot of chaos and turbulence on its surface. This turbulence creates strong magnetic fields that can produce dangerous radiation and bursts of particles, which would be tough for planets like Proxima B, which are in the habitable zone. Until recently, scientists didn't know much about the magnetic field around Proxima Centauri. But thanks to a new study using advanced maps, we now have a better idea. The study showed that Proxima B gets about 1,000 times more radiation from the star's solar wind than Earth does, which could be risky for any life that might be there. Back in April 2021, Proxima Centauri, the star near Proxima B, had a mega flare, which is like an extremely powerful burst of energy. This flare was a whopping 100 times stronger than any flare ever seen from our own sun. Just imagine how bright and intense that must have been. It's hard to think that anything could survive such a blast of radiation without special protection. While the idea of a planet like Proxima B being a comfortable home for life is exciting, the reality is probably not so friendly. The conditions there would likely be very tough for living things. As humans, we've always been curious about the idea of meeting aliens. Our interest peaked in late 2020 when a strange signal was detected coming from the Alpha Centauri system, where Proxima Centauri is located. What's fascinating is that this signal has a frequency of 982.07 MHz, which is not the kind of frequency we usually hear from our satellites and spacecraft. Some experts think it might be from a piece of equipment, but others hope it could be a sign of intelligent life out there in the universe. But could there truly be life in such places? Proxima B's atmosphere. Strange life in an intense planet. Recent data from the JWST tells us something exciting about Proxima B. That far-off planet we've been studying might have water vapor in its atmosphere. This is a big deal because water is important for life to exist. Finding out if Proxima B has water or not is really important, like solving a big puzzle in space. Scientists are using all sorts of advanced tools, like spectroscopy and atmospheric modeling, to study Proxima B's atmosphere from far away. To tackle these challenges, we must enhance our telescopes and sensors and potentially develop novel methods for space travel. Consider the prospect of new propulsion systems capable of propelling us to distant star systems at velocities surpassing our current capabilities. This advancement would revolutionize exploration and foster unprecedented discoveries. Presently, scientists explore various innovative concepts such as solar sails utilizing sunlight for spacecraft propulsion and ion propulsion, which expels particles to generate thrust. The concept of warp drives, reminiscent of science fiction, is also under discussion, proposing the bending of space to enable faster-than-light travel. However, these concepts remain theoretical, necessitating extensive research and testing before practical implementation for interplanetary exploration. Nevertheless, contemplating these possibilities is exhilarating, envisioning a future where technology might facilitate visits to celestial bodies like Proxima B, unraveling their enigmatic secrets. Embarking on a journey to Proxima Centauri B, the nearest star system to ours, evokes the tantalizing notion of encountering extraterrestrial life forms. Such a venture, though once deemed improbable, now captures the imagination as scientists within the Breakthrough Initiatives endeavor to shorten the voyage duration from centuries to mere decades. However, a significant obstacle looms, ensuring sustained acceleration as the spacecraft nears the speed of light, an endeavor fraught with immense challenges given the staggering velocity involved. With current technology, a voyage to Alpha Centauri, a constituent of Proxima Centauri, would span approximately 6,000 years. The Starshot project offers a compelling solution, employing lasers to propel spacecraft towards Alpha Centauri. Yet, the endeavor is complicated by atmospheric interference, hindering precise laser guidance. Bandhu Tunga, the project's lead scientist, proposes utilizing adaptive optics technology to mitigate this challenge, employing small satellites equipped with lasers to monitor and compensate for atmospheric disturbances in real time. Although demanding substantial energy, akin to the electricity consumption of the entire United States, these lasers, albeit momentarily, empower the spacecraft's propulsion. By deploying millions of lasers across a vast expanse, the spacecraft could attain velocities reaching 20% of the speed of light, enabling a swift journey to Alpha Centauri within 22 years, a timeframe eclipsing the span of many lifetimes. The expedition to Alpha Centauri, though promising, confronts formidable impediments. Chief among them is gravitational interference from the Sun and space debris, potentially impeding spacecraft velocity. Furthermore, even upon reaching Alpha Centauri, communication delays could persist, necessitating 4 years for messages to traverse the vast expanse to Earth. Scientists, exemplified by Bandutunga and Sibley, tirelessly endeavored to safeguard the spacecraft against perils en route, necessitating precise engineering to withstand intense thermal stresses. Ensuring the spacecraft's mirror achieves near-perfect reflectivity is paramount, facilitating efficient heat dissipation. Moreover, maneuverability to alter trajectory swiftly is imperative, mitigating overheating risks. Notably, the project's scalability offers a promising prospect. Once perfected, subsequent spacecraft launches could be conducted at a reasonable cost, augmenting the scope of interstellar exploration and enhancing the prospect of discovering Earth-like exoplanets. This endeavor embodies the boundless possibilities of space exploration, heralding a new era of discovery. The James Webb Space Telescope, JWST, stationed at the second Lagrange point, L2, approximately 1.5 million kilometers from Earth, represents a pinnacle of astronomical instrumentation. Positioned at L2, the JWST maintains a stable orbit, akin to finding the optimal vantage point amidst a bustling crowd. Endowed with an array of sophisticated instruments, the JWST is poised to unravel the universe's mysteries, including the quest to identify Earth-like exoplanets. Notably, the JWST's scrutiny extends to Proxima B, offering a tantalizing glimpse into this enigmatic world. Leveraging its adeptness in detecting various forms of light, particularly infrared radiation, the JWST unveils celestial phenomena imperceptible to conventional telescopes. Boasting a colossal primary mirror comprising 18 hexagonal segments spanning 6.5 meters, the JWST captures unprecedentedly detailed images, surpassing the capabilities of its predecessors. This prodigious capacity enables the JWST to discern faint signals from distant celestial bodies, akin to spotting a firefly amidst profound darkness from afar. Let us know what you think about what JWST released about Proxima B in the comments below. And if you enjoyed watching this video, make sure to give it a like and subscribe to the channel.